Yeah, well, okay. So welcome to the fourth day of National Science Week. So today the first talk will be delivered by uh, Dr. M. Prithviraj, of the director of this MCNS. So Professor V.J. Gopalakrishnan will be introduced him. So I just invite Professor Dr. Gopalakrishnan to be here and introduce Dr. Prithviraj.
Thank you, Dr. Chakraborty. I again welcome all of you who have joined in this room and also through Teams or YouTube to this afternoon talk of the fourth day program of the Science Week this year. And today's talk will be given by Dr. M. Prithviraj, and the subject he has selected is water management. Dr. Prithviraj, I wonder at the foresight his parents had in giving him this name. All of you may be wondering also, because Prithvi means earth and Raj means a leader, a neta, a king. And appropriately, he has specialized in geology. And wherever he goes, somehow or other, the positions of the earth and the planets push him to a position of leadership. And we have seen it here. And today he is going to talk on water management. And I recall when we go to the old book, I don't know the new books. If you see the old books, some old theory books of economics, you will see about the initial pages will talk about free good and economic good. Economic goods are those which are scarce, and free good are just publicly available. The examples used to be air and water. At least those days it was believed air and water is free and available everywhere. Wherever you go, you just go and ask for water. Nobody has any problem to give. Now it is expensive. So water has become so expensive and it has become an economic good, and water management, and there is a ministry for water. All those things have become important these days, relevant these days. And now a few lines from his biodata, very little from his biodata. Dr. M. Prithviraj, after completing his PhD in marine geology from Mangalore University, served for over 25 years in the government of India in the Department of Space, ISRO, and the Department of Science and Technology as a scientist. On deputation to the Karnataka State Council for Science and Technology, IISc Bangalore, served as its executive secretary for 5 years. He is now, as you all know, serving the Manipal Academy of Higher Education as director in charge at the Manipal Center of Natural Sciences. He has undergone training on ocean mining in West Germany and on synthetic aperture radar interferometry at the University of Cape Town, South Africa, and has participated in the scientific cruise on ORV Sagar Kanya, that is ocean research vessel Sagar Kanya, at the Central Indian Ocean Basin. He managed programs on earth sciences, earth sciences, glaciology, tsunami, and a mission program on war for water at DST. He also played a key role in the designing of the national mission on sustainable Himalayan ecosystems at KSCST, that is Karnataka State Council for Science and technology, he ideated and implemented several novel outreach programs and implemented a region-to-region collaborative program with France and Israel. This Science Day Week program we are enjoying presently are going on in the format suggested by Dr. Prithviraj. And now, maybe I can give a quotation because it's going to be on water. Actually, our ancient belief, as seen by the scripture, it says, "Apo vai idagum sarvam." It means water is everything. So I'm telling the first two, 3 words, but if I tell the full thing, it says practically, it lists all the things. Practically everything is water, because the life depends on water. If there is water, we say that there could have been life there. So it is such an important thing and so venerated. And now, with this small introduction, I request Dr. Prithviraj to talk on his chosen subject, integrated S&T approach to achieve sustainability in water resources. Dr. Prithviraj.
Thank you, Dr. Gopalakrishnan. Actually, today I'm going to play the recording, which I did a couple of days ago, because I'm having some kind of a health problem, like I'm not able to speak very continuously for a long period of time. So with the help of Mr. Ram Prakash and Ganesh, we did this recording, and I am thankful to them. And also, there was an uncertainty whether I would be attending this session at all, because there was a meeting arranged, but then it got shifted. So with this few words, today anyway, we will see the recording, and then whatever I have to say, I've already said in that, and including the introduction. So let us go to the recording, please. Thank you. But I am around here to answer any queries. I'll be present, and I shall answer the queries at the end of the talk. Thank you. People who have assembled here, my colleagues, and also people who are watching this presentation online. This is one of the 14 presentations we had lined up as a part of our National Science Day festival activity. We are actually in the Manipal Center for Natural Sciences are organizing a 7-day program to kind of spread different aspects of science to the interested school children, then college-going students, as well as for the general public. Earlier, when we used to host the event at our center, wherein people used to come here and then participate in our programs. But this year, due to COVID restrictions, we are actually conducting this online. In this lecture, I'm trying to touch upon a point on water management. So actually, this year's theme is integrated S&T approach for sustainable future. Accordingly, I have tried to look at the water management aspect that could be achieved using different using the different institutions in the government to kind of participate and collaborate with each other and find the possible solutions that the country is facing in the area of water resource management. Now I go to my presentation. Yeah, so this year's theme of National Science Day is integrated approach in S&T for sustainable future, which has been declared in the month of January by our Honorable Minister for Science and Technology, Dr. Jitendra Singh. So in this particular theme was very carefully chosen to create public awareness on solving societal problems using scientific methods. Now, for most of the problems, we are able to provide solutions using certain scientific and technology that is available with us. Going further, he also mentioned that the era of working in silos is over, and in order to find solution to the problem that remains in any area impacting the society is lying in an integrated approach. Thereby, he stressed that there is a need for cooperation from all the stakeholders to kind of arrive at possible solutions to the problem that the country is facing. He mentioned 4 pillars of integration of science. The first one is on the science ministries and the departments to work together on team-based approach to problem solving. So there are 8 or 9 departments of science, and he mentions that since they have been doing this kind of research all these years, they should now identify certain themes and then come together to find problem to those particular solutions to those particular problems. Second one is science integration with technical, engineering, and medical institutions. It is necessary that the government also takes kind of goes to these institutions of higher learning because this is the place where a lot of research keep happening at the ground level, and then most of the students and faculty, they are engaged in creating new knowledge as well as in innovations. So it is necessary that we also go to these technical institutions and other centers of higher learning to find solutions to our problem. Then he mentions that the science ministries, when they come together to solve a problem, they should also go in consultation with some of the line ministries who need these solutions, and then work with them very closely to kind of orient and bring them on in their research and implement the outcomes of the research for the betterment of the society. Then finally, he also mentions that there is a need for involving the industries and especially the startups to sustainably deliver the science-based solutions that have been designed and discovered to address the societal problems and kind of implement it within the society. So, taking cue from this, I tried to look at the one aspect, that is the water resources that exist in the country, the problems that exist in the country in the area of water. So in order to achieve sustainable water resource, I just thought that there is a need to look at some integrated S&T approach. And in this particular presentation, I'm only looking at some of the functions and activities that are actually going on within many of the departments and ministries at the central level, and then trying to kind of flag them so that there is a possibility to find solutions to the prevailing problems of water resources. The problems associated with water can be broadly categorized as availability of water. First of all, nearly 97% of the water that is found on the earth is locked up in the oceans, and it is not fit for human consumption and also for several of our uses. But only 3% is the fresh water, and in this fresh water also nearly 98 to 99% is locked up in either glaciers or ice caps or in the ground. So the active water that we see on the ground in the form of lakes, rivers, soil moisture, etc., they form only a very, very minute component of the water that we see on the earth. So nearly 73% of the water world over is consumed for agriculture, and only 20% is consumed for industry and domestic and recreational uses. Then comes the second point, the quality of water. So whenever we say quality of water, the quality is defined by its usage. Some of the times the quality may be considered as good if it is for certain other purposes other than drinking or for irrigation, etc. For instance, if you want to wash a car, you don't have to use very good quality of water, whereas for drinking, there is a need for good quality water. So for the intended use, the quality is defined. Then comes indiscriminate use of the resource. Yes, we have found this very true in many cases because most of the resource is indiscriminately used, especially in the irrigation segment, because the governments have given free electricity to some of these villages and farmers, and they just switch on the pumps, and then most of the water, more than what is required for the crops, are used. So this has to be properly controlled. The problem of water in India can be classified as below. One is the uneven distribution of rainfall in time and space. Our country receives good rainfall in certain places and it doesn't receive much rainfall in several other places. And also the timing of the rainfall. Sometimes it is in time, sometimes it goes haywire. So this is one of the major problems that we have been facing time and again. Sometimes, most of the time, we feel there are some droughts affecting the country in certain places, so due to failure of monsoon. We are dependent on monsoon for our agriculture, and if it fails, then most of our cropping pattern go haywire, and then we are not in a position to produce the kind of agricultural products that we need to consume. Then intensive agriculture. Many a times when there is sufficient water for certain crops, we try to overstretch and then try to create more intensive agricultural activities so that we don't very clearly judiciously use the resource that is available to us. Suppose in a particular place, the area is suitable for good normal agricultural crop jawar and things like that. We try to go in for a highly water intensive crops like sugar cane and then paddy and things like that. So thereby creating more inequality in the availability of resources. Then industrial development. Industry requires a lot of water for production development. So for instance, if you have to produce electronic items, I'm told that it takes quite a lot of water. And then that is one reason why we have to be very careful while setting up industries and see we are able to optimally provide them the necessary water resources for their development. Urbanization. So urban pockets are developing now, and the requirement for water is also increasing extremely high. So even here, more than the requirement, the water is being used. So we have to bring water from other different places through several mechanisms, either through pipelines or through road transport or through rail transport and all that. And that is creating another inequilibrium in the usage. Then contamination. Contamination is both natural and anthropogenic. Natural contamination to some extent can be controlled, but then anthropogenic, it is happening, and then there are very severe kind of laws have to be in place to control this anthropogenic contamination. Natural contamination have taken place in certain places which have gone beyond our control, but then it could be to some extent curtailed. We could try to kind of avoid using water with natural contaminants for our daily use. Liberalized policies like giving free power for pumping and for irrigation and things like that have led to extensive use of water. Climate change, that is also creating a havoc today, and it's nowadays we are getting rains in different seasons when we don't really expect them to be, and droughts in certain other places and extreme snowfalls and things like that. So climate change is also bringing in some kind of inequilibrium in the system. In India, 92% of the water is used for agriculture and around about 3% for industry and 5% is for domestic purposes. So R&D efforts in water resources should primarily aim at bringing about improvements in technologies to plan, investigate, develop, and manage the resource efficiently. When I say plan, suppose if you want to plan irrigation programs, projects, then we have to use the technologies that are available at our disposal, like remote sensing technology and several other surveying technologies to properly locate the structures, irrigation structures, and align the canals, etc. Then in the course of investigation, we have several new techniques which have come into picture for investigating the groundwater sources, investigating the soil percolation levels, then moisture content, etc. So we have to use them very effectively to kind of plan our delivery systems. And in the development of the technology, the development of the project itself, we need a lot of new technologies for actually implementing the process of building dams, canals, and such other structures. Then finally, managing the resource. So using some of these technologies, we can prioritize areas where the water is required most and where the water may not be required to the extent that is being supplied there. So all this can be done, and then we can optimally use the resource using these technologies that are available with us. And our usage should also be environment friendly, and we should not spoil the environment around us by using extremely high amount of water and creating problems like soil salinity and things like that. So the water demand is growing, and it is required that we have to somehow attain sustainable resource management for equitable distribution of the resource. So the R&D should try to kind of aim at all these aspects and then come out with strategies and plans for implementation. During the year 2009 or 10, the Department of Science and Technology had taken up a program called War for Water. In this, the main challenge was to provide good drinking water supply to the community. So while implementing the program, the Department of Science and Technology had a consultative meeting with a wide variety of users of water and also some of the departments and ministries engaged in water resources. Through these discussions, nearly 27 different kinds of water challenges have been identified that the country is facing. One is the low per capita availability, then about the water quality due to natural sources, biogenic sources, soil salinity, and seawater intrusion, etc., and also human pollution and other aspects. Then non-optimal use of water by agriculture is another area, unplanned use for the demand of the resource, and then evaporation, loss, etc. So there is a need for sustainability, to bring sustainability in water cycle management. At the moment, it is mismatched. The withdrawal and recharging of the water resource is very much mismatched, and we are actually exploiting the groundwater resources to a great extent and creating a lot of stress to the system. Then there are several water bodies which are lying in disuse. Like in earlier days, there used to be village ponds, then wells, and such other water bodies. But then today, they are all in disuse and they're not being taken care of properly. Then we have several technologies wherein the reject water is high in salt content. For instance, reverse osmosis technology. So we have to kind of manage this reject water and also tune the technology to kind of reduce the reject of this water from the system. There are several new water winning technologies coming up, and we have to look at that also. Then flood management. One is the river flood management. The other one, which is much more alarming, is the flooding of the cities. So there is a need for immediate action to manage the floods, both in the cities as well as in the natural environment. Then wetland management. Wetlands have also become mismanaged, and they have become areas of high pollution. So there is a need to kind of manage the system so that it returns to normalcy and we're able to sustain the ecosystem in these wetlands. In water resource management, there are different components. The one is knowledge, our own knowledge of water and experience as to how we had managed the resources in certain locations and in certain situations. So this has to be properly kind of taken into consideration while planning the new strategies for water resource management. Then we have the technology. Technology is ever improving to produce and win water from different segments, which were hitherto not heard of. Like now we are able to kind of win water from moisture, win water from snow, create snow, and such kind of technologies are available. I don't know how far they are feasible, but then technology is definitely available. And then there are well-tested technologies like groundwater kind of satellite remote sensor technology for groundwater estimation and things like that. Then economy. We have to look at the economic aspect also. Like if we use certain technologies, the technology may not be viable and it cannot be applied on a wider scale. So economic considerations need to be taken into consideration while planning the resource management strategies. Society. Society is ever demanding, it's growing, and then the requirement also keeps increasing. So we have to look at futuristic requirements and plan for the future well in advance. Stakeholders. All the stakeholders should participate in this so that it becomes a common agenda for all of us, both government, non-government, and industry, and the common citizens. Everyone has to participate in water resource management strategies and implementing them successfully on the ground to reap the benefits. Now let's see what the different ministries are actually doing in the either directly or indirectly in the water resource management strategies. First and foremost, the Ministry of Water Resources. This is the ministry, nodal ministry for water. They have to take care of water for human consumption, cattle, and such other life forms. Then water for food, that is for irrigation, and water for nature to kind of maintain the ecosystem, and water for industry and other uses. So they are the nodal ministry and they have to plan for all these requirements. Basically, their main objective is to frame policies for development, regulation of the resource, protection of the resource based on the already ongoing or completed research. Then they also have to provide directions for implementation of large-scale water resource development projects. like large scale construction of dams, canal system, river linking, etc. Then at the ground level also, they have to help in adoption of the technologies that are available, feasible, and popularize them with people to accept and practice. National Water Policy 2012 looks at the requirements of the projected water demand for food security and promotion of general health of the prospective population in 2050. So the planning has to be in line with the projected demand of 2050, both for water, food, and other requirements. When you look at this map, this is the water supply and demand gap map of 2030. Here, except for a small region in the topmost part of India, which is very, very sparsely populated and not very easily accessible, and a portion of the Brahmaputra and related valley in the northeastern region, all other places are suffering from water stress. It could be moderate or it could be severe. So the policy has aimed at maximizing the conversion of available water of 1,000 billion cubic meters to utilizable water. Today we may have this much water available to us, but then all that is not useful. We have to find ways to use them effectively and consume it. Optimize the use of utilizable water to yield maximum benefits. So out of this 1,000 BCM, whatever water we find today as utilizable water, it has to kind of yield its maximum benefit. It has to serve its purpose to the maximum. Suppose I use it for irrigation, it has to give me very good yield. Suppose I use it for industry, it has to provide me very good products. So it has to be, the usage has to be optimized at all levels. Then prevent the resource from being rendered unfit for use through pollution control. So large portions of the rivers and lakes are polluted today, and there is a need to kind of control this menace and see that the water pollution is brought to the minimum possible levels. Ministry, coming to the Ministry of Science and Technology, this ministry has a mandate to kind of go for development of new technologies, upgrade the proven technologies, upscale the production and demonstration of these technologies at the community level, create awareness among target groups, and promote research to produce new knowledge. So the main objective of this department is to kind of carry out research to understand the system in different parts of the country through small groups engaged in research at the institutions of higher learning or research, and then also use this knowledge and kind of assimilate it and produce new strategies for adoption by the other ministries and at the community level. So this is one technology which had been developed by IIT Madras. Professor T. Pradeep of Chemical Engineering Department has produced this. This is called Amrit. This is arsenic and metal removal by Indian technology. That is Amrit. So they have used nano materials for purifying the water that is contaminated with arsenic. So this, they are popularizing it, and now it's been adopted by many people and communities. Even while I was working at the Karnataka State Council for Science and Technology, we had interacted with this group and placed a few of these systems and a larger system at Hatti gold mines for because arsenic poisoning is prevalent in certain pockets close to the Hatti gold mines. Ministry of Earth Sciences. So this is a newly formed ministry, and then their main objective is to map the gross hydrological cycle over India, map the evaporation, evapotranspiration rates of different parts of the country, then develop decision support system, mathematical modeling for futuristic implementation, then deployment of proven technologies for water conservation and purification, cloud seeding, and inducing of rains. So this is the picture of low thermal desalination plant, which is called as in Lakshadweep's islands. They had implemented this. Here, it's a flash distillation process through which the cold seawater that is drawn from a deep ocean is kind of distilled, and then fresh water is condensed and being supplied to the community. The kind of distillation process is it requires only very small gap in the temperature regime of the water, like around 4 to 5 degrees of difference in temperature between the cold deeper waters and the slightly warmer upper waters is enough to produce this effect of distillation and then condensation of the water and taking that water, pure water, to the use of the community at the Lakshadweep. So they have already planted several such systems in the islands, and now the island is not facing much problem for drinking water. Ministry of Agriculture, the major user of water, and they have to kind of develop specific agriculture practice for different agroclimatic regions to kind of bring down the usage of water, like kind of different systems of production, cultivation, like terrace farming, and also different types of crops, like dry crops in certain dry areas, which are very efficient and use very less water for their growth. Then also they have to contribute for water saving strategies by developing new systems of cultivation one, then micro irrigation. There are several crops that can be cultivated using micro irrigation techniques, like sprinkler irrigation and such other systems. Then develop new varieties of crops that can grow in water deficient conditions develop cost-effective materials for retention of water on the surface, like absorbent polymers and things like that. So this is one such system wherein it's in a powder form, but then you spread it on the surface, but then when there is water, it just absorbs the water and then releases them very slowly to the for the use of the plants. Then improve the water conveyance efficiency through canals and systems like that. Also, pollution. Agriculture practices do cause a lot of water pollution at a very, very wide scale. So in order to reduce that, they have to find new means of pesticides and fertilizer usage so that it does not affect the groundwater greatly. Then organic farming. Develop easily degradable chemicals and organic farming practices for reducing the pollution. Ministry of Health, they too have a role to play in providing clean drinking water for all of us. One is the prevailing problem in water is fluorosis and arsenic contamination. So when you have arsenic contamination, the skin becomes produces rashes, and then eventually the person on a long-term exposure may undergo a lot of health problems. In order to avoid and be cautious, the Ministry of Health has established several water testing laboratories all across the country who regularly monitor the quality of water that is being produced and provided to the society. Arsenic poisoning and fluoride poisoning normally comes with groundwater usage. If you use the river waters, then the poisoning is not much, unless otherwise the river water itself carries some of these materials from the source area. Then they also work towards improvement of sanitation to reduce the pollution arising out of general waste, human waste percolating into, and bacteria and other kind of pathogens percolating into groundwater and affecting the shallow groundwater aquifers. So they have defined several protocols which requires to be followed for kind of accessing good drinking water from pump wells and others sources that are available in the pump well, as well as wells and other sources that are available in the village. Development of safer and efficient techniques to control waterborne diseases. So waterborne diseases also is a major concern, and then most of the water that is stagnating has to be properly treated so that they don't breed dangerous pathogens and also mosquitoes and other such. Then coming to the Ministry of Environment, Forest, their main objective is to protect the aquatic environment and also improve the forest cover for improving precipitation, infiltration, and better surface and groundwater resource generation. So animals and humans, we all need water, and then humans need water for not only drinking and bathing, but also for recreation and other activities. So this water has to be kept fairly clean and should not create any problem for the health of both animals and human beings. So that is the main task of Ministry of Environment and Forest. Then also growing forest, maintaining the forest cover of the country so that it kind of reverses the impact of climate change and anthropogenic impacts that are being brought out in different conditions. CSIR, the Council for Scientific and Industrial Research, their main objective is to develop newer technologies, and specifically they have established several institutions whose main objective is to sectorally look at the problems in different areas and then try to find solutions for it. Then the technologies that are developed has to be kind of inexpensive, widely applicable, and then could be used on a wider scale all over the country by different segments of users. Then also assess the technologies that are indigenous and compare it with the imported technologies and improvise the indigenous technologies to suit our requirements. Arsenic and fluoride contamination and purification of this is one such technology which they are looking at. Then development of and application of new methods of water management strategies. So this is one example of scientists who have developed in CSIR NCL Pune called SWASTIK. It is Safe Water and Sustainable Technology Initiative from Indian Knowledge Base. This is an amalgamation of technology with Ayurveda to offer solutions for clean drinking water. So this is being kind of used by many societies, and they are reaping the benefit of this technology. This is a TerraFill water filter, wherein they have developed a new system of water filter using some of the locally available materials. Department of Biotechnology. The main objective is to do research, and maybe they could develop drought resistant crop varieties, then microbial degradation of pollutants and effluents, and application of nanotechnology in water purification and remediation. Department of Space. Department of Space is mainly they launch and operate many satellites which are continuously monitoring the country for several aspects. In this, by using the satellite technologies, it is possible to kind of monitor the surface water bodies and then estimate the reserves in reservoirs. Then also look at the status of surface water bodies, how good they are, or whether they are contaminated, to what extent they are contaminated, and etc. Then demarcate and delineate groundwater potential zones using remote sensing signatures, estimation of evapotranspiration, etc. They also can monitor land use, land cover changes that are taking place, and the kind of agricultural extension that is happening, and then soil moisture conditions of the terrain. Then vegetation stress can be monitored easily. Then the progress of water developmental activities, such as kind of building of new waterways, then canals, etc., can also be monitored. This is one temporal picture of a reservoir being monitored by satellites. So seasonal monitoring of the kind of water availability, the extension of the reservoirs, kind of storage capabilities, etc., can be easily assessed. This is a picture of the countrywide picture of irrigated, non-irrigated, and non-crop area. This also can be seasonally monitored. The dynamics can be easily understood so that sufficient interventions could be planned for better utilization of the resources that are on the ground. This is plot level information wherein the red areas indicate water stress conditions, green areas indicate water availability conditions, and using this precision agriculture could be also practiced. Ministry of Rural Development, they too have a stake in the water management. They are supposed to be adopting scientifically developed technologies and the techniques for providing safe water to the community and for the use of domestic use as well as livestock requirements. Then preservation of hygiene, health and ecology, and protection of water sources at the village level. Then traditional water harvesting structures, like they are supposed to be implementing some of these. This is the picture of a check dam, wherein how they have to plan and how they are going to use the resources that are available to produce such kind of dams to improve the percolating water storability and percolation, etc. at the village level. Ministry of Urban Development. Natural water cycle is thrown out of gear when you have a city, because when there is a precipitation, the water goes into infiltration, runoff, and evaporation modes. So this is what happens in a natural environment. But when you have a city, then we have precipitation, and then the precipitation doesn't infiltrate into the ground because of the coverage of the ground by concrete and roads, etc. So they just flow away from the city. So large volumes, they get out of the system, and then we import water from different system altogether, and there again we create some kind of inequilibrium in the system. Then evapotranspiration is pretty high. Rather, evaporation is very high because of the dryness of the terrain. Then we also discharge a large quantum of wastewater into the system. So all this has to be managed properly in order to have a very healthy society within the urban locales. This is a picture of a urban flooding which have taken place recently. Now this has become a common feature in most of the cities. We had it in Chennai, we had it in Bombay, and we are also having it in certain other portions of the country. And during those periods, in a couple of days, you receive tremendous amount of rain, and we are not in a position to kind of convey this water out of the system. So they tend to kind of flow overland and create a lot of damage to the property and life people living in the cities. So there is urban ministry should take care of water towards provision of safe and sufficient domestic water. They are taking care of this. Then protection of aquifers through regulation. This has to be intensified because there should be laws to kind of put bore wells, and then to what extent they can withdraw water from the bore wells, and what are the other kind of responsibilities to kind of enrich the groundwater, etc. has to be thought of. Then they have to promote sustainable use of the resource, manage the storm water, tackle pollution issues by zoning, industrial zoning as well as other kind of zoning, so that the pollution aspect is reduced tremendously within the zone of the city. Then sanitation and solid waste management has to be in place. Then they have to also look at rainwater harvesting strategies for augmenting the water requirements. So this, many of the cities are now slowly and steadily adopting, and I am sure very soon most of the cities will have rainwater harvesting techniques in place. Ministry of Commerce frame policy to reduce virtual water export and increase virtual water import. So what is virtual water? Virtual water is the kind of water, the amount of water that we use to produce, a product. For instance, 1 cup of tea of 250 ml takes away 27 liters of water. It doesn't mean that I take a bucket of water and then try to produce 1 cup of tea. It means that to grow the tea leaves and also process them to reach that cup, it takes that much of water. And then for other crops also, it is specified here. 1 egg of 60 grams contains 200 liters of water. So you have to grow the chicken, then you have to transport it, and then when it reaches your plate, it's about 200 liters of water has been already spent on it. So for instance, meat takes 15,400 liters of water, and 1 glass of wine costs around 110 liters of water. So this is the kind of water requirement for each produce that we consume on a daily basis. So we have to ensure that we import more billions of liters of water than export them through our different produce. So if you look at the Indian annual export-import of rates of virtual water in billion liters per year, you will find that nearly around 100 billions, around 70 billions of virtual water being exported, around about 30-35 billion liters of virtual water is being imported. So this red has to kind of increase, and the blue has to decrease. Geological Survey of India and Central Groundwater Boards. They are attached to Ministry of Mines and Ministry of Water Resources, and they are the major agencies for aquifer mapping, mapping of natural water bodies, and water quality assessment, etc. And they keep on producing on a regular interval different types of maps related to water, surface water, groundwater, etc. So these are all information that gets generated on a country-wide scale at very regular intervals. So coming to the end, we have to intelligently leverage the capabilities of the stakeholders for finding solutions to the water challenges. The stakeholders here, I could only look at the government departments, but there are other stakeholders as well, like the innovators, industries, and the daily our own population. All are stakeholders here. So we have to use them intelligently. So in case of government institution, as the minister had mentioned, the science ministries and departments could work together to find solutions to the water challenges of the country, support innovation and technical, engineering and medical institutions for solutions, because this is a place where a lot of young brains and active people are working, and then they would be in a position to find out-of-the-box solutions to most of the prevailing problems that we face in the country. Then continuous stakeholder consultations and needs assessment have to be in place to look at different line departments and their requirements in terms of water, and we have to design the solutions in such a way that it satisfies their requirements. Support from industries and startups for production of efficient technologies and management of the resource by the society is to be ensured. So I have used a lot of images from the internet, and I am thankful to the original authors of the images. So thank you very much once again. So in this case, water is very crucial, and we have to somehow very intelligently use all our resources, all our might together, and then come out with solutions that are replicable at the ground level to achieve sustainability of in the future. Thank you very much.
Yeah, thank you. Thank you, Dr. Prithviraj, for this nice presentation. So it is now time to have some questions. So do you have any question? Yeah, Dr. Gopalakrishnan.
I have two questions. One is, in certain seasons or certain areas, naturally there is excessive rain, and that is the reason why it is unmanageably excess. And in other seasons, there is drought kind of thing. There is no rain, and there is problem of absence of water, and problems of avalanche of water and problems of absence of water. These two problems are there in the same place. And people are talking about connecting rivers, and this has not appeared in these plans. I think I didn't notice it. And my question is whether connecting the rivers is a technical solution, because when you connect rivers, maybe when one place like Tamil Nadu, if it doesn't have enough water, probably the other state which has more water can supply water if it is connected. But the reverse is never true, because the water cannot go from Tamil Nadu upwards at all. So in case Andhra or Karnataka is starving for water and Tamil Nadu has excess rain, the reverse is not possible. The connection of water is not going to help each other. So is it really a solution, technically speaking? This is number one question.
Yeah. I did mention about the river linking in one of the slides, but then it was a passing comment, passing reference, because I personally believe it's not a real solution. Of course, there are some people who very strongly believe in river linking project. Actually, when you go into the history of river linking project, you will see that it was proposed by one of the Indian Airlines pilot, while he was flying over the country several times, he felt that the rivers could be linked and ultimately they may yield very good water to the entire country. Okay, as a pilot, yes, he's correct. But as a water manager, what happens is you try to link the rivers, you are trying to bring in equilibrium in the system. Rivers, every system has some equilibrium. Suppose I link Ganga with something else, some other river, there is likelihood that there may be less water in the main river, more water in the connected river and things like that. There's another thing also, like when there is rain, heavy rains in one place, they tend to transfer that floods to the next place. So it's not an easy thing to do on a countrywide level, but people are, some of them are very convinced that it is possible, and only one linkage has come up, some Betwa and something, some river, one small linkage has come up, and they're trying it out. I was also involved in a lot of discussions at the central level when I was there, the DST, but then I personally don't believe in river linking as a solution to our problems.
I have a second question. You are talking about water being wasted, and there are efforts to produce new water, like desalination, etc. And there is the demand for water also grows. So these three things: the rate at which the demand grows, the rate at which water is proposed to be produced, and the rate at which water is getting wasted. I think these two should be connected in the planning. Because, for example, if in this production of water is going to be very expensive, desalination, etc., and probably it is easier to reduce the wastage. So relatively, so these two things should be
definitely
connected.
yes, definitely. You'll have to look
Yes.
at everything, like any resource. Not only doesn't restrict to water alone. Any resource, even power at home. If you're not there, you just switch on the fan. Unnecessarily, you're paying electricity and it's getting wasted. And somebody else in a village suffers because of this wastage. Bangalore alone, they say that power wastage is also high, water wastage is also high. So because of which the surrounding villages, not only the surrounding, the other parts of the state do suffer certain shortages. So any wastage is criminal. So that has to be controlled. But then you said something else also. This production. Production actually, especially this LTTD, that is low temperature thermal desalination. They use some liquid ammonia, some kind of a thing to kind of instigate that flash distillation process. I was told that one bottle of water as big as a Bisleri bottle costs 10 paise production cost. So it's not very high. At the same time, it's not applicable everywhere. Suppose I want to put it here, there are only very, very limited places where I get that temperature gradient wherein this can be implemented. So it cannot be implemented in most of the places. But in Lakshadweep, I have seen, initially when I used to go there, water used to be a problem. We used to carry water also for 2-3 days at least, then drink their water. The water that they give is brackish and it creates health problems for people like us. So later when I went, I found people using this LTTD water even for construction. That is how they got so much water. Kavarati has one plant, Agati has one plant. and some other 3-4 islands they have established. Wherever it is established, it continuously yields water because they can't stop and start and all. It continuously keeps happening, and it's a pure good water that you drink there. Even I could drink it, no trace of any salt. It's taken from the sea, and everything, the process, entire process is done with sea water, and still you get very fresh water. It's an amazing technology.
Rain and rivers and all. Is great.
I showed you in the beginning itself.
Yeah.
Groundwater is about 23% or something like that of the fresh water. Groundwater.
But that does not contribute.
That is what is contributing to all our daily needs these days. Who goes? You go to Bangalore, everybody has got a bore well. And that is one reason why every 5th year you have to dig deepen the bore well, because everything goes away. People are drawing water just like anything. And then I was told, while I was discussing, this was about 10-12 years back, while I was discussing with one of the fellows in ISC Bangalore, he was mentioning that in Paris, there are only 3 deep bore wells. Come to Bangalore, there are more than 30 lakhs bore wells. Whatever we do excess. You go abroad, cell phones, they use it very limited. Here, every 5th minute, I want to know where he is, where he is, where he is. So that is how it is. We try to overuse many things, and that causes damage. Chennai, nowadays, even if you put bore wells, I don't think you are successful in getting good water. So these are some things.
So our online participants can unmute their self and can ask questions. So is there any? Hello. Our online participants can unmute their self and ask questions. Is there anyone? If okay, there is a comment from LS Chamal that is despite being unwell, excellent talk. Please take good care of your health.
Thank you, Dr. Chamal. Yeah.
So
Thank you.
If there is no question, let us thank the speaker again, and we will assemble again in 5 p.m.
Thank you.